It's really valuable when you get an error to look at the error message. It can tell you a lot. First, the first thing you notice is that there's that pink box and that you got an error. And then you may be tempted to just go look at your code and try to figure out what's wrong. But it's really worth investing the time to look at the error message. It'll tell you a line number, which will be a good clue. And if you start to learn to decode the specific messages, they will also be really helpful. So let's go through an example here. Here's a program that's going to ask for a couple of inputs. It's going to ask what time we want to start, how long we want to wait, and at the end it's supposed to print. So if I enter 3 o'clock, or 3 is our start time, then I want to wait 4 hours, it should tell us that that's 7 o'clock. So let's see what actually happens. What's the current time in hours? Let's say 3. How many hours do you want to wait? 4. And it should print out 7. But instead we get that pink error box. Let's go see what it's telling us. It says, first of all, that line 5 is a good place to look. It says the type of problem that we have is a name error, and in particular, wait time int is not defined. So let's go look at line 5. This means that it actually executed 1 through 4. Everything was going fine until it got to line 5. Whenever you see an assignment statement like we have on line 5, what happens is we first evaluate the right-hand side, the stuff after the equal sign, and then we'll assign it to the variable wait time int. So it's going to get a value, but it only gets that value after we manage to evaluate the right side. So the right side says to look up the current value of wait time int, but it is not defined. So by the time we get to line 5, wait time int has not previously been set. So when you try to look it up on line 5, we get this error. So that should give us a clue. Now we have to go back to what we were trying to do and figure out what's going on and say, oh, wait a minute. We were trying to take this input that we got that was going to be a string that was maybe 4 hours, but this isn't the name of the variable. Wait time str is the variable. So if I do that, I have a better chance of it working. Let's see if that does. I start at 3. I say that I want to wait 4 hours. And now I get the 7 that I was expecting to get. See you next time. You can reduce your headaches as a programmer by writing your programs incrementally. Get something working and keep it working. That's going to be our mantra. Or start small and keep it working. Here's a program where we're trying to draw a house, a rectangle with a triangle on the top. And we've done the first part for you, get something working. But I'm now going to try to add to it in a way that lets us draw more and more of the house, and when we make mistakes, to catch them before there's too much code. So we've started with something that's working. Bob is going down and turning left. Let's complete that square. That should be pretty easy to do. Just make him turn left again and go forward. You might be tempted to do more lines of code than that, but I really recommend testing after you write every little bit of code. So let's turn him again. And we'll test that. Then we're going to get to the slightly harder part. So now I want to make him turn this way so that he can finish the house like that. So let me do that. Instead of turning left, I'm going to want to have him turn to the right. And instead of 90 degrees, let's just try going 45 degrees. We'll go halfway, and then we'll have him go forward by our 50 again. Oops! This is why it's a good idea to do things a little bit at a time, because I'm going to get to realize already that I am going the wrong direction. So I wanted him to turn to here so that he would go that way, but he didn't go far enough. He turned 45 degrees, but I really needed him to go all the way around to there, so another 90. So I need him to go 135 degrees. Oh no! Almost, but not quite. And you can try just doing trial and error until you get something that's pretty close, or sometimes it really helps to step back and do a calculation. In this case, the Pythagorean theorem, remember that, can really help us. We want to make something that is 50 here and is going to be a right triangle there. If we have some length a, we need a squared plus a squared to equal 50 squared. So you could do this in a calculator, or you could have the Python interpreter work it out for you. There is a square root function. It's a little tricky. You have to import the math module. And then we're going to say distance is the square root of 50 times 50 divided by 2. And then we will have Bob go forward by that distance each time. Let's try it and see if we get a nice roof on the house this time. Yay. So the main point that I wanted you to take away from this was that you're unlikely to get it all right the first time if you just write a really long program. It's much better to start with something that's working, add a line or two, test it, and make sure that you continue to have a program that is working. So build up and always keep your program working. Let's go through some common errors. These are typical mistakes that programmers make. So it'd be helpful just to have seen some of the error messages and how to recognize the problems and how to fix them. So one that we've already seen is forgetting a parentheses. Here it tells us there's a syntax error. It doesn't really know exactly what's wrong, but it tells us there's a syntax error on line 6. Whenever you see a syntax error, you should always look on the line number that it says. If everything looks right there, you should really look on the lines above it. In this case, we forgot to close the parenthesis on line 5. So even though it says line 6, it's line 6 where the Python interpreter realized there was a problem, but it's on line 5 where you really have the problem and where you should correct it. So we should add that parenthesis. And now it works. Our next set of errors involve variable names. The first thing to realize is that capitalization really matters. In this case, we got to line 3, and on line 3, it tries to do capital turtle dot small turtle. First thing to know is that capital turtle and small turtle are two completely different variable names, and small turtle is the name of this module. In that module, you can find the turtle class. So we really needed to have small turtle dot capital turtle. So another example of a variable naming problem occurs here. And sometimes you got to watch out when we have a big window to draw in that there may be an error message down below. In this case, the name right is not defined on line 6. And you might look at this and say, this is all just fine. We're telling June to go right by 90 degrees. That's not the correct way to say it. We first have to mention the object, and then the dot, and then the method. So June should go right by 90, not right.June. So let's fix that. And now we get it without the error message. Here's another variable naming problem. We create a turtle named June, and then we tell June to move right by 90. Again, the error message is down off the screen, but it's saying June is not defined on line 6. So we're telling June to go right. There's no binding for the variable June. There is a binding for the variable small j June. So this is a situation where small j June, capital J June, not the same variable. And so we got that error. Fix that. No more error there. Another common type of error is when we invoke a function but don't pass in the right values, the right arguments that it's expecting. So here we've got a program where June is supposed to move forward and turn right and do that repeatedly. But we didn't tell it how many times to do it. So we invoked the range function, but we didn't pass in an argument saying how many times to do it. We get an error, and it tells us that on line 5, we tried to invoke the range function. It wanted to have at least one argument, but we didn't give it any. There are no values in the parentheses, and it wants at least one. So we should have said something like, do this 3 times. Let's give it an argument of 3. and now it works just fine. You may also notice that on line 7, we passed the string 50 instead of the number 50. In some situations, that would cause an error. But the forward method for turtles was implemented in a way that allows us to pass either a number or a string that can be cast to a number. So it's okay. So those are some kinds of common errors that you're likely to see as you start writing your own programs. We'll see you next time. Congratulations! You've picked up some valuable debugging skills. Remember, your programs aren't going to work the first time and you shouldn't expect it, but with the debugging skills you've started to pick up, that won't be a problem for you. At this point, you should be able to distinguish between syntax, runtime, and semantic errors. You should be well on your way to developing a habit of looking at the error messages and developing a skill of interpreting them. Learn to love your error messages. You should be internalizing a mantra, get something working and keep it working. Celebrate the small wins, and in order to celebrate the small wins, you first have to have those small wins. And finally, you should now be recognizing some common errors and how to fix them. So today's joke. A manager, a mechanical engineer, and a programmer, they're driving back from a convention, going over some mountain roads, and suddenly the brakes fail. And they fly, they're careening down the mountain. They're scraping against the guardrails, and fortunately they finally stop in a ditch, to their great relief. All three of them, they get out and they start to assess the damage. The manager says, let's collaborate, let's share our ideas, work together on this, and we can solve this issue. The mechanical engineer says, well, let's disassemble the whole car, and we'll analyze each part for failure and figure out what went wrong. And the programmer says, hey, why don't we just push the car back up the hill and go back down and see if it does it again. Solve this issue. The mechanical engineer says, well, let's disassemble the whole car, and we'll analyze each part for failure and figure out what went wrong. And the programmer says, hey, why don't we just push the car back up the hill and go back down and see if it does it again. Now, don't be that kind of programmer. Be more like the mechanical engineer. Read the error messages, figure out what's wrong. Your life as a programmer will be a lot more pleasant. We'll see you next time.